explain the studies we did for Concawe on the contribution of shipping and aviation to air quality. This is the agenda I have in mind. Short introduction, how we approach, something specific on the emission data we used, then the results of the maritime study, aviation study, and then overall conclusions. Well, we were commissioned by Concawe to determine the contribution of shipping and aviation emissions to the local air quality in cities. Why? Of course, legislation will reduce emissions from industrial sources and also from road transport. And so other sources will become more relevant. And the objective of the study was to give Concawe data to enhance the understanding of the role of shipping and aviation emissions in the current air quality in major cities, and then specific harbor cities and cities with large airports. Well, just an overview of the emission trends in Europe. What you see is we have a decline in emissions overall. This is for NO2 of NOx. And you see that the shipping, the G category, and also, let's see, no, the G category is relatively small if you see it, if you look at the European level. It's far below the emissions of road transport, for instance. But this is for Europe-wide. But locally in cities, it can, of course, differ. And that's what we investigated. Our approach was that we use our Lotus Euro's TNO chemical transport model, which has a labeling feature in which we can label the sectors of the emission sectors and follow them throughout the model. We run the model at the first run at 25 by 25 kilometers and followed them by runs of 6 by 6 kilometers and in some cases 1 by 1 kilometers. For the maritime study, we targeted 13 seaports and 6 inland ports. And for the aviation study, we calculated for 6 major international airports in Europe. Well, this is a picture which explains a little bit how this air quality model works. We have a numerical model which is fed by the meteorology, land cover and soil data, emissions, and then we can calculate the concentration of different components in ambient air. Well, the emission data sets we used, we calculated for the components NO2, SO2, PM2.5 and PM10. We used the CAMS original version 5.1 inventory, which is made by in a project for the CAMS Copernicus program by TNO and some other contractors which compile an inventory for Europe and even for global emissions. This CAMS-REC inventory is based on the national inventories of the member states, but, and that's for shipping very important, the national shipping data which are reported to the commissions are not all emission data, because they don't cover the emissions on the international seas. So that's important to do. And also this data set includes non-anthropogenic sources which might be relevant. For instance, SO2 is also influenced by volcanic activities. And for the high resolution runs at 1 by 1, we had NO2 emission inventory on a 1 by 1 kilometer scale. And in the process for Germany and the Netherlands, we had also a high resolution set, which was used to in the airport studies and the aviation studies, where the airports were defined as surface sources and not as point sources, as in other emission inventories. I touched upon the emissions from shipping in national inventories. What I did here is to look into the inventories for the countries surrounding the North Sea, and totals those components in the inventories which are relevant for shipping together. And you see that in the last line, the total, if you sum it up, it comes down to 974 kilotons NOx. But in the CAMS database, only 429.3 kilotons is in there. And the main issue here is that although the emissions from international maritime traffic, so outside the national waters, are to be reported in the memo item, but the memo item covers only fuel sales for bunkering, and a lot of those emissions are not within the domain of this research. So that's why we use the CAMS regional data set. And we calculate for these ports, I don't mention them all, you can see all major and interesting ports are in there. Inland ports are not that many because, well, they are concentrated around the big rivers in Europe. And I will show you the results from the maritime study. In the left panel, you see the total concentration of NO2 in Europe, following all sectors. And in the pie chart at the right, you see the contribution of the different source sectors to this average concentration. Please bear in mind, this is the average concentration over the total domain. So if you zoom into detail, it will become different. But you see, at this level, 18.2% of the NO2 concentration can be explained by international shipping. So that's not negligible. These are the results for SO2, PM10 and PM2.5. And there you see that the contribution is less than for NO2. But for SO2, of course, relevant contribution due to the sulfur content in the maritime fuels. So what you see here is two pictures of the absolute contribution of international shipping to the NO2 surface concentration in Europe. On the left, you see international shipping. It's clearly you can clearly see the main shipping lines over the North Sea, in the Mediterranean, also in the Baltic Sea. And for inland shipping, on the right, you see that you can you can see the River Rhine, and if you closely look into the pictures in the report, you can also see the Danube appearing on this map. But you see that the contribution of inland shipping is less than what we see for international shipping. This is the same picture for the relative contribution of shipping, international shipping on the left, inland shipping on the right, to the NO2 surface concentration. And you see that especially maritime transport has a big contribution to the NO2 levels in Europe. For the inland shipping, this is far less. Now we zoom into a harbor. Because we are in Belgium, we choose for Antwerp. You see the result of the calculation on the 6x6 resolution on the left side, and on the 1x1 kilometer on the right side. You see, when you go to lower resolutions, you get a far more detailed picture. You see a green dot and a blue dot, and in all next figures, the green dot stands for harbor location and the blue dot for the city center, because we have to refer to a specific point in, on the map when we do the analysis. Well, here on the left side, the 6x6 resolution, and then you see the contribution of the different cell sectors to the NO2 concentration in, on the left to Antwerp city, and on the, sorry, on the left, the Antwerp city. My glasses are not up to speed anymore. And on the right, the Antwerp port. And you see that in the port, it can be, the NO2 concentration can be determined for 47% due to international shipping. The inland shipping is far less. That's I put the arrow, it's the deep purple color. If you go down to 1 by 1 kilometer resolution, the percentages change a little bit because you then have no smearing of emissions and concentration. So higher resolution gives you a better picture, but for the contribution from international shipping, it's even higher than calculated on the 6x6 kilometer. All the charts I presented for Antwerp, they are in the report, which can be downloaded from the website at Concawe, are available. So I try to summarize here what are the results of the maritime study. And you see that the contribution of inland shipping to the concentration in the harbors can be significant. For Rotterdam, you see that inland shipping, 29% of the NO2 concentration in Rotterdam can be explained by emissions from inland shipping, and 13% for international shipping. And you see also the main harbors like Antwerp, Amsterdam, Hamburg, they all have a large contribution of shipping to the NO2 concentration in the city. So that's an important finding of this study. International shipping will become more significant when you want to tackle air quality in port cities. What you also see is that the contribution of inland shipping is order of magnitude lower than the international shipping. That comes from this picture, and you see that for the main inland shipping harbors like Duisburg, Cologne, they have the highest contribution, but you see there Nijmegen, that's on the border of Germany and Netherlands, where the Rhine enters the Netherlands, and all the shipping, inland shipping from which goes to Germany and over the Rhine crosses Nijmegen, and it's a very narrow strip of river, or not very narrow, but close to the city center, and that's why you have there a very high contribution of inland shipping to the NO2 concentration. So, summarizing everything, trying to summarize everything in this graph, and if you watch to the, it's light purple bars in comparison with the red bars, you see that in some cities the contribution of shipping is even higher than the contribution of road transport, and will be growing relatively when road transport emissions will go down. Now I switch over to the aviation study. These are the airports we calculated for London, Paris, And then for 3 airports, Amsterdam, Frankfurt am Main, and Munich, we had a more detailed emission mapping for the airports, and then also for Brussels in Belgium. Again, here on the left, the annual average NO2 concentration in Europe, and again, the relative contribution of the different source sectors. And you see that aviation is only a very small percentage of the NO2 contributing to the NO2 concentration in Europe. Also here we first did the 6x6 kilometer resolution runs. And you see here also, again, the green dot is the harbor of Amsterdam. And now I switch to Amsterdam because I'm from the Netherlands, so I'm a little bit chauvinistic. The blue dot is the city center, and the green one is Schiphol Airport. And you see there is not much definition in the 6x6 kilometer resolution run. And we can go to the right, the 1x1 kilometer resolution. And you see that the definition is far more shown. If you know the airport of Rotterdam, we have a lot of landing strips and takeoff, which are far away from the airport itself. If you look closely, you can see the landing lanes. One of is from the north to the south. In this picture, we show the difference between road transport on the left and aviation on the right. This is the relative contribution of the source sector road transport to NO2 concentration in Amsterdam area. And you, on the right, you see the definition of the roads and the city center. And on the left, you see the definition of the landing strips. But you see also here, close to the airport, the contribution of aviation is significant. About 60% of the NO2 concentration near the airport can be explained from aviation emissions. So these are the bar charts, the pie charts for the 3 locations. On the left down corner, that's the that's the airport, and you see that. Let's see, did I do it correctly? You see that the colors a little bit changed, but at the airport, about more than 30% is due to aviation emissions. In the Amsterdam port itself, it's about 20 kilometers to the north. It's gone down to 8%, and in the city center, it's 4.5% of the NO2 concentration can be attributed to aviation emissions. So the distance is very important. Results of the aviation study overall, you see that the annual contribution in of the aviation contribution to the annual NO2 concentration in the city centers is not that big, but it can be up to 12%, up to 5% of the total concentration. And how big this contribution is of course the distance to the airport. In some, like Amsterdam, the city center is far away from the airport, but in other cities, the airport can be very close to the city center. So it asks for a specific approach and analysis. So here again, the bar charts with the contributions of all the source sectors. And what you see here is that the aviation emissions are order of magnitude lower than international shipping and also far below the road transport emissions. The left bar is at the airport itself, and the right one is at the city center at the airports, near the airports. So, coming to the conclusion, international shipping can be a dominant contributor to NO2 concentration in cities. The highest ones we calculated were Bremen, Le Havre, and Genova, with around 50 or more % of the NO2 concentration was explained by the international shipping emissions. International shipping is now the second biggest fraction contributor to the NO2 concentrations behind the road transport exhaust emissions. For other pollutants, the percentages are what lower because they have other sources have far more higher emissions for PM and SO2. And what we also see is that inland shipping on the whole in Europe is only a minor contributor to air quality, but for specific cities near the river, they can be significant. Well, for aviation, the emissions contribute far less, order of magnitude lower than from international shipping, but near airports, and especially those airports which are in the vicinity of residential areas, this is not the case. There is the contribution higher. Well, overall, you can say that both the maritime and the aviation sector will become more important when you want to improve air quality in the future. Key in making the correct analysis is, well, the spatial resolution on which you perform your analysis, and also use the correct emission data. These are very important. And using a labeling tool like we did for the source apportionment, well, it gives you a very good indication on what the different sectors contribute to the total concentration. I didn't speak about this, but in the reports you find comparison of our model results with against observations, and I didn't go into detail, but it can be found there. I put some references. The two blue references are the reports which can be downloaded from Concawe, and the Coenen et al. Describes how the CAMS registry inventory was compiled, and the last one, Johansson and Jalkanen, these are describing how the STEAM model of FMI in Finland calculates the emissions from international shipping based on IES data.